Okay, Assalamualaikum warahmatullahi wabarakatuh and dan selamat sejahtera. So now saya akan memberi teknik menjawab soalan PSPM SK025 for session 2017 and 2018. Question number 5 and question number 6. Okay, so please refer the question number 5. N2O5 decomposes to NO2 and oxygen according to the following chemical equation. So the chemical equation is given. Table 1 shows the change in concentration of N2O5 against times when the reaction is performed at 50 degrees. So this is the data given. So kita akan please refer to the question. The question is determine the order and the rate constant for the reaction by using a linear graph method. So maksudnya this question is specifically to determine the rate constant and the order of reaction by using a linear graph method. And then from the graph, what is the half-life of the reaction? Okay, so your strategy, what is linear graph method? Okay, so what is linear graph method? So the integrated equation will give an equation that relate with the linear equation. Linear equation is y equal to mx plus c. So make sure you can remember and derive the integrated equation for first and second order of the reaction. So for the zero order, the integrated equation will be A naught minus A equal to KT. So A naught minus KT equal to A. So if we make A as a subject matter, so A equal to negative KT plus A naught. So if we use this integrated equation, compare with the linear equation y equal to mx plus c, so means your y-axis is concentration of A, x-axis is the time, okay, your gradient is equal to the value of rate constant. So we need to plot for zero order, we need to plot a graph of concentration of A as a y-axis versus t time. For the first order, the integrated equation will be ln A naught minus ln A equal to KT. So ln A will be ln A naught minus KT. So kita pindahkan KT to the left side. So ln A equal to negative KT plus ln A naught. So if we compare this integrated equation with the linear equation y equal to mx plus c, so your y-axis is the value of ln A, x-axis is t, so your gradient is equal to the rate constant. Okay, so c is the value of ln A. So for second order, okay, the integrated equation for second order is 1 over A minus 1 over A naught equal to KT. So kita jadikan 1 over A is a subject matter. A equal to KT plus 1 over A naught. So kita compare dengan linear equation y equal to mx plus c. So your y-axis is the value of 1 over A. So x-axis is the value of t. K rate constant equal to value of the gradient. So untuk second order, you need to plot a graph of 1 over A, concentration of A versus time. So first order, you need to plot a graph of concentration ln A versus time. Okay. So then, from the data given, so this is time, this is concentration. So then you need to find the value of ln concentration N2O5, and also you also need to find the value of 1 over concentration of N2O5. Okay, so 0 is when ln 1, so we will get 0. Ln 0.77, we will get negative 0.261. Ln 0.6 is negative 0.511, and so on. Okay, after you get the data, so you will plot a graph. So kamu kena cuba-cuba. So kita kena cuba-cuba graph. So first we need to plot a graph concentration of N2O5 versus time. So okay, so the y-axis is concentration of N2O5. Your x-axis is time in minute. So if you get your graph is not a linear graph, so let's say your graph is not a linear graph. So this is not a linear graph. So since the graph of concentration of N2O5, okay, versus time is not linear graph, so therefore the reaction is not zero order. So let's say pada masa ini kamu lukis graf dan kamu dapat linear graph, straight line. So pada itu ialah zero order. So let's say, so sekarang ni kita plotkan graph concentration versus time, tak dapat linear graph, so graph dia melengkung. So macam tu dia melengkung, so dia bukan zero order. Okay, then kita plotkan graph, we plot a graph of ln N2O5 versus time. So this is the graph of ln, bukan A lah sebab dia dah specifically. So ln concentration of N2O5 versus time, so kamu akan dapat satu linear graph. So since the graph of ln concentration of N2O5 versus time is linear graph, ataupun kamu boleh cakap straight line graph, so therefore the reaction is first order reaction. Okay, so let's katakan kamu lukis graph ln N2O5 versus time pun kamu tak dapat linear graph, kamu kena cuba graph yang ketiga, iaitu graph 1 over A versus time. So maksudnya kat sini kamu kena cari data 1 over concentration of N2O5, kemudian plotkan graph 1 over N2O5 versus time. Kalau kamu dapat linear graph, so itu ialah second order. Okay, so okay, so because the question asks you to plot a graph, okay, using linear graph method, so make sure kamu kena buat pada skala yang betul lah. So kamu mesti ada title kat sini. So title dia adalah graph ln concentration of N2O5 versus time. So kamu mesti label y-axis as time in the unit of minute, and x-axis is time in the unit of minute, dan y-axis is ln concentration of N2O5. Okay. Okay. Lepas tu soalan kata, the question asks you to, from the graph, what is the half-life of the reaction? Okay, so half-life of the reaction. So, okay, so dia suruh kamu cari half-life. So kamu tahu bahawa half-life for first order, kita dah determine first order daripada graph sebab dia ialah kita dapat dia linear graph because of graph ln concentration versus time. So untuk first order, the formula of half-life is ln 2/k. So the k value ni kita kena get from the graph. Okay, dan saya dah buktikan macam mana kita nak dapatkan k. Okay, saya dah buktikan kat sini. Okay, untuk first order, the value of k equal to the value of the m, which is m is gradient. So kamu kena cari dulu gradient, pilih titik yang terbaik. Okay, so find the value of delta y, find the value of delta x. Okay, so gradient, okay, m equal to the value of k. So kamu nak cari gradient m equal to delta y over delta x. So delta y, y2 over y1 over x2 over x1. Okay, so kat sini, so this is the value for y2. So this is the value for y1. So here is the value for x2. This is the value for x1. Okay, so from the graph, we found that the value of the gradient, the value of gradient is 0.271. So this is will equal to the value of k. Okay, after we get the value of k, we can calculate the half-life. So half-life, so ln 2 over, put the value of k, 0.271. So you will get the value of half-life will be equal to 2.56 minutes based on the calculation. Okay. Okay, then given the EA of this reaction is 58 kilojoule per mole, calculate the rate constant at 65 degrees. Okay, so T1 initial concentration is 50 degrees with the value of K1. So we have already calculated from the previous is 0.271. Okay, T2 is the new temperature, which is 65 degrees. So we want to calculate the value for K2. So by using the formula ln K1 over K2 equal to EA over R, 1 over T2 minus 1 over T1. So masukkan nilai. So okay, the value for R is 8.314 and the unit for R is joule per mole. So since the unit for R is in the unit of joule, so given the value of EA is in the unit kilojoule, so you need to convert kilojoule to joule. So the value of EA 58 kena times 10 for the power of 3. Okay, the value of temperature for each T1 and T2 you need to convert to Kelvin. So degrees darjah Celsius convert to Kelvin, you need to add. Okay, T1 is 50 plus 273.15. T2 is 65 plus 273.15. So you will get the value of K2 is 0.707 per minute. Okay, next question is compare the rate constant at two temperatures and explain in terms of collision theory. So first you need to relate the temperature and the collision theory, the effect of temperature with the collision theory. So as we know that at the higher temperature, the average kinetic energy of a molecule will increase. So the number of collision will increase. So at the higher temperature, more molecule will gain energy greater than activation energy. So number of effective collision will be also increase. Okay, so kita mesti tulis number of effective collision increase. Sebab the rate of reaction memang very depending on the number of effective collision ataupun only the effective collision that produce a product. Okay, so when the number of effective collision increase, so the rate of reaction will increase. So hence, when the rate of constant increase, so the rate of constant will increase at the higher temperature. So, okay, so kamu mesti relate collision theory dengan temperature, kemudian kamu akan relate the rate constant dengan temperature. Okay, next question is describe how the addition of catalyst will affect the rate of reaction. So dia suruh describe, means kamu kena explain. So first kamu kena mention catalyst will provide an alternative pathway with the lower activation energy. So apa effect dia? So more molecule will have an energy more than the activation energy. Okay, then when more molecule will have the energy than activation energy, mesti ada perkataan effective collision as I mentioned before, because only the effective collision that produce a product. So number of effective collision will increase, so therefore the rate of reaction will increase. Okay. Okay, so that's all how to solve ataupun the alternative answer for question number 5 for question number 5 for year 2017-2018. Now I will proceed to question number 6. Hexane can exist in many isomeric form. Draw all the structural formula. So draw all structural formula of hexane. So macam mana kamu nak lukis? Make sure kamu lukis ada 3 cara untuk draw the structure formula, whether you want to use the condensed structure, expanded structure ataupun skeletal structure. Okay, so the first structure is 1, 2, 3, 4, 5, 6 carbon. So kat sini H ada 14. So kat sini ada 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is the first structure. So the first structure, C6H14 in the form of straight chain. So structure number 2, kita buat satu branch. So sekarang dia daripada longest skeletal 6 kita jadi 5. Okay, the second the one branch at carbon number 2. So kita completekan number of hydrogen. So make sure kamu kena completekan number of hydrogen. Kalau kamu guna condense ataupun expanded, hydrogen need to be shown. Okay, so kalau kamu guna skeletal tak perlu. So 3, 4, 5. Sorry, 3. So ini yang CH2. 3, 4, 5, 6, 7. So sini 1 hydrogen, 8, 9, 10, 11, 12, 13, 14. So they are ada one branch at carbon number 2. Okay. So still the longest chain is 5 carbon, tapi kita move the branch at carbon number 3. Okay. So sini 3, 5, 8, 11, 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 1H, 14. Okay, structure number 4. Okay, so now we change the number of carbon skeletal for the parent. So daripada 5 kita reduce to 4. Okay, so kita letakkan branch at carbon number 2 and carbon number 3. So sini CH3, 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 so 9, 10, 11, 12, 13, 14. Okay. Structure number 5. Okay. Okay, so kita letak branch at carbon number 2, 2 branch. So sini adalah 3, 6, 9, 10, 11, 12, 13, 14. Okay, so I think there are 5 isomeric structure for C6H14. Okay. Sebab kalau kita ubah this one, pindah kat sini, dia dah jadi structure yang ini sama. Okay, so dia tak adalah. Okay, next question. Is there any chiral isomer? Explain your answer. So, kita nak chiral isomer, kita mesti tahu kalau chiral isomer, dia must have chiral center ataupun chiral carbon. So kita mesti cari dulu chiral center ataupun chiral carbon. So what is chiral center ataupun chiral carbon? Carbon atom bonded to 4 atom ataupun 4 different atom ataupun group of atoms. Okay, so kita pergi check structure kita satu persatu. Okay, so ni C terikat dengan 3H, so this is not chiral. C terikat dengan 2 atom H, which is same atom, not chiral. So this is not chiral. Carbon terikat dengan 2H, not chiral. Carbon terikat dengan 2 atom H, not chiral. Carbon terikat dengan 3 atom H, not chiral. Second structure, carbon terikat dengan 3 atom H, not a chiral carbon. 2 atom H, not chiral carbon. 2 atom H, not chiral carbon. 3 atom H, not chiral carbon. 3 atom H, not chiral carbon. Carbon terikat dengan H, okay. Tapi dia terikat dengan 2 metal. So this is also not chiral carbon. Carbon bonded to 3 hydrogen atom, not chiral. 2 hydrogen not chiral, 3 hydrogen not chiral. 2 hydrogen atom not chiral, 3 hydrogen atom not chiral. Carbon bonded to H, okay. Tapi dia terikat dengan 2 ethyl. So which is 2 same group. So this is also not a chiral carbon. Carbon bonded to 3 hydrogen not chiral, 3 hydrogen not chiral, 3 hydrogen not chiral, 3 hydrogen not chiral. Carbon bonded to H, tapi dia terikat dengan 2 metal, so this is not chiral. Carbon terikat dengan H, okay, tapi terikat dengan 2 metal which is same, so this is also not chiral. So structure, the last structure number 5, carbon bonded to 3 hydrogen not chiral, 2 hydrogen not chiral, 3 hydrogen not chiral, 3 hydrogen not chiral, 3 hydrogen not chiral. So carbon bonded to 1, 2, 3 metal. So this is also not chiral. So selepas kita check one by one, so kita dapati, is there any chiral isomer? So jawapan dia no chiral isomer. There are no chiral isomer. Explain your answer. Kenapa? Is there any chiral isomer? Jawapannya no chiral isomer. So kenapa? Explain. Because there are no chiral carbon ataupun no chiral center. Okay. Next question, name the type of bond cleavage when isomers of hexane undergo halogenation reaction in the presence of light. Okay, write an equation to show this bond. So as we know that hexane, okay, hexane, the bond between carbon and hydrogen have similar electronegativity. So bila dia undergo similar electronegativity, dia akan undergo homolytic cleavage. So dia suruh kamu buktikan halogenation reaction in the presence of light. So dia suruh kamu buktikan. So kita boleh pilih any isomers daripada 5 ni. So let's say saya pilih isomer yang first. So isomer yang first ialah CH3, CH2, 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 CH3, okay. React with, undergo halogenation. Halogenation reaction ialah tindak balas add halogen, add bromine, chlorine, fluorine in the presence of light. So this one, okay. So kita tahu kalau write an equation to show this bond. Okay, so react with bromine. Bromine, okay, bromine ataupun Br2, okay, in the presence of UV. Okay, so dia undergo homolytic cleavage. Okay, dia undergo homolytic cleavage. So dia kata write an equation to show this bond cleavage. Show bond cleavage. Bond cleavage mesti menunjukkan bahawa dia bahagi bonding sama banyak. So kat sini dia bagi sama banyak. So carbon akan attract one electron, H akan attract one electron. Kamu represent dengan single headed arrow kat sini. So dia akan jadi free radical. CH3, CH2, CH2, CH2. So 1, 2, 3, 4. CH2, CH3. Hilang satu jadi CH2. So jadi free radical ni pada carbon sebab carbon tarik satu elektron. Plus H akan jadi free radical, dia akan attach pada Br, jadi HBr. Okay. Okay, so name the type of bond cleavage. The type of bond cleavage ialah homolytic cleavage. Okay, so actually kamu dah claim homolytic cleavage, dia sebenarnya nak tengok kamu punya produk kat sini ialah free radical tu. So dia nak tengok kat sini mesti tunjukkan free radical. Okay, kemudian dia nak tengok kat sini macam mana bonding antara carbon dengan H ni, dia akan membahagi sama banyak gunakan half-headed arrow kat sini menunjukkan carbon tarik satu elektron, H tarik satu elektron. Okay, so we move to the next question. So question number 6b, hydrocarbon S C8H8 react with hydrogen in the presence of platinum catalyst to yield T. C8H10 compound U is formed when T is heated with alkaline potassium permanganate solution followed by hydrolysis. So the reaction of S with hydrogen bromide gives V, whereas ozonolysis of S produce W and methanol. Draw the structures of S to W, give the name of the reaction for the conversion S to T, write all the chemical equation involved. So untuk soalan macam ni, saya advise kamu convert dia kepada flow chart. Okay. So dia kata hydrocarbon S, so S with the formula C8H8, okay, react with hydrogen, so plus hydrogen in the presence of platinum as a catalyst, dia akan produce T C8H10. Compound U is formed when T is heated with alkaline potassium permanganate solution. So T heated, dipanaskan dengan kalium permanganate, dipanaskan, followed by hydrolysis. Hydrolysis acidic medium, hydrolysis mesti air berasid, kemudian dipanaskan, so dia akan produce U. Okay. The reaction of F with hydrogen bromide, so S react with HBr, so dia akan produce V. Okay, so ozonolysis of S, produce W and methanol. So ozonolysis of S mesti 1 react with ozone, so number 2, followed by hydrolysis with zinc water in the acidic medium. Okay, zinc water. So dia akan menghasilkan methanol, menghasilkan produce W dan methanol. Methanol, the structure of methanol adalah C double bond O H H. So this is the structure of methanol. Draw the structure of S2W. Okay, so untuk soalan ini, so methanol dah diberi, so kita nak lukis mana dulu? S dulu ke, T dulu, U dulu, V dulu? Okay, kita mesti tahu S ni mesti sejenis alkin. So kenapa S sejenis alkin? Sebab alkin dia ada unsaturated carbon-carbon double bond. So unsaturated carbon-carbon double bond bila undergo ozonolysis, so dia akan break carbon-carbon double bond, so dia akan produce sama ada aldehyde-aldehyde, keton-keton ataupun aldehyde-keton. So S ni ialah sejenis alkin. So since karbon ni satu, dia dah jadi satu karbon kat sini. So kat sini C8, so dia dah remove satu karbon. So mesti W ni mesti ada C7 karbon dia. Sebab total dia ini ada satu karbon. So 7 campur 1 mestilah 8. So kita kena cuba untuk lukis structure untuk W. So kita akan lukis W dahulu. Okay, so kalau kita buat C7, okay. Okay, so dia mesti menghasilkan sama ada aldehyde ataupun keton. So kalau katakan dia menghasilkan aldehyde, okay, so inilah 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So sedangkan hidrogen kat sini 8 je. So kat sini ada, kalau C7, H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 tak cukup. So maksudnya dia bukan straight chain. Dia bukan open chain. So kita kena cuba lukis yang lain pula. Okay, so kita cuba lukis kalau ada benzene ring. So benzene ring ini ialah C6H6. Okay, dia hilang satu H sebab terikat dengan, katakan sini karbon, jadi C6H5. So sini kita ada ini dah 8. So sini 1. So kita sini 6 campur satu lagi 7. Okay, kalau kita ada double bond kat sini. Okay, so sini C6H7. So karbon ini ada sekarang C6H6, buang satu jadi C6H5. So karbon kat sini ada 1, 2, 3. So sini ialah H. Sini ada CH2. So kat sini ada 1, 2, 3, 4, 5, 6, 7, 8. So H8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. C8 H. 1 kat sini. 2, 3, 4, 5, 6, 7, 8. C6H8. Okay. Okay, tapi sebab kita tahu kalau ozonolysis of alkene dia mesti akan menghasilkan aldehyde ataupun keton. So kat sini kalau dia ada, kalau C7 maksudnya dia lebih satu karbon. So kat sini C, okay, ini ialah C7. Ni satu karbon. So maksudnya sini karbon dia mesti 7 sebab total dia 8. So 1, 2, 3, 4, 5, 6, 7. So kalau bila ada satu karbon tak mungkin jadi keton. So dia akan jadi aldehyde. So C double bond OH aldehyde. So this is the structure for W. Kenapa saya lukis macam ni? Sebab metanol dah ada satu karbon. Number of carbon is 1. Okay, so means W mesti number of carbon dia 7. So 7 dia mesti ada. Kalau saya lukis benzene adalah C6H6. Kalau saya tambah satu lagi karbon, so bila saya buang satu karbon, H untuk terikat dengan karbon, dia jadi C6H5. Okay, terikat dengan satu karbon lagi, jadi C6 campur 1 jadi C7. H5, 1, 2, 3, 4, 5. So karbon kat sini terikat dengan satu H. Okay. H6 ada satu O, double bond O. So this is the structure for W. So kita lukis W dahulu. So bila kita dah lukis W, kita boleh lukis structure for S. So the structure for S will be, okay, so saya lukis, kita dah tahu struktur bagi W. So W ialah double bond OH. So kita boleh tahu lukis structure untuk S. Macam mana saya lukis structure untuk S? Saya combinekan W dengan methanol. So carbon ni kita combine, kemudian kita potong O. So bila saya combine dia akan jadi C. O dah tak ada, so terikat jadi double bond C. C terikat dengan H, C terikat dengan CH2. So sebelah sini, ini daripada methanol, ini daripada W. So this is the structure for S. So structure for S will be okay, adakah formula dia C8H8? So carbon ada 1, 2, 3, 4, 5, 6, 7, 8. H ada 1, 2, 3, 4, 5, 6, 7, 8. So this is the structure for S. Okay. Kemudian kita boleh, bila dah tahu structure bagi S, so this is structure bagi S. So saya lukis kat sini. So structure bagi V will be, okay, S ialah, so saya salin balik structure ni. Ini structure bagi S, CH, double bond, CH2. Ini adalah S. Bila react dengan HBr, okay, tindak balas mesti sentiasa follow ataupun obey Markovnikov. So bila dia obey Markovnikov, H akan masuk pada carbon yang lebih banyak H. So H masuk kat sini, Br akan masuk dekat sini. So the structure for V will be CH. So double bond dah jadi single bond. So sini CH2 plus 1 jadi CH3. Ada Br satu kat sini. So this is the structure for V. So kita salin balik structure untuk V adalah benzene ring. So sini CH2 plus 1 jadi CH3, ada satu Br. So ini adalah structure bagi V. Okay. Kemudian so V done, W done, S done. So kita akan lukis bagi structure bagi T. So T, bila kamu dah tahu structure bagi S, okay, kalau nak jadi T, so saya okay, saya salin balik structure bagi S yang ini, benzene, CH, double bond CH2. Bila campur dengan hidrogen platinum, so apa yang dia akan buat, double bond ni dia akan jadi single bond. Okay, so dia akan jadi single bond, dia akan jadi structure ini. CH3. Okay, so structure bagi T adalah so S jadi CH, sini CH2, CH3. Okay, structure bagi U. Okay, so U, compound U is formed when T is heated with alkaline potassium. Okay, so ini adalah structure bagi T. So ini adalah structure bagi T. T bila react dengan kalium permanganate followed by hydrolysis, heat, Okay, ini ialah tindak balas oxidation untuk alkyl group, substituen yang terikat dengan benzerik. So pada carbon ni, yang terikat dengan benzerik ni ada 2 atom H. So means this carbon can undergo oxidation. So undergo oxidation dia jadi apa? Dia akan jadi benzoic acid. COOH. So this is the structure for you. Saya salin balik. So structure for you will be this structure. COOH ataupun C double bond OOH. Okay. So untuk selesaikan soalan macam ni, so saya rasa lebih mudah kalau kamu buat flowchart, kemudian kamu tulis apa information yang kamu tahu kat sini, dan kamu mesti boleh predict S ni mesti alkene yang mana ada carbon-carbon double bond, sebab alkene undergo ozonolysis akan produce aldehyde. So W ni mesti aldehyde. Okay, sebab macam saya cakap lah tadi, so sini dah satu carbon dia satu, so mesti sini carbon dia 7. So bila sini carbon 7, bila ada benzyl memang tak mungkin akan jadi ketone, dia akan jadi aldehyde. Okay, so kita nak dapatkan S, kita kena combine W dengan metanol, so dapat S. So kemudian dah saya rasa dah bila dah dapat S, mudahlah. So kita tahu alkene react dengan HBr, jadi V, alkene react dengan hydrogen platinum jadi T. T ialah alkyl benzene undergo oxidation. Carbon yang terikat dengan benzyl ni ada at least one hydrogen, so dalam kes ni ada 2, so dia boleh undergo oxidation. Okay, so the next question is, draw all the structure of S to W is done. Give the name of reaction for the conversion S to T. S to T. Okay, S kepada T. So S kepada T, S ialah alkene, tindak balas dengan hydrogen platinum. So the name of this reaction is hydrogenation. Tindak balas penghidrogenan. Okay, so saya tulis kat sini. Conversion S to T ialah tindak balas hydrogenation. Okay, next question is, okay, done. Sebab dia bukan bagi, dia suruh bagi type, dia suruh bagi nama. Kalau type of reaction barulah addition, electrophilic addition, nucleophilic addition, free radical substitution, nucleophilic substitution, and so on. Tapi dia suruh bagi nama. So nama ialah hydrogenation, oxidation, reduction. Okay, itu adalah nama. Write all the chemical equation involved. Tulis semua persamaan kimia yang terlibat. So actually saya dah tulis dalam flowchart ini. Tapi mungkin kalau dalam exam macam ni tak berapa jelas kan. So tak apa, kita akan tulis balik. So bila kita dah dapat compound yang sesuai tadi. So S tadi ialah kita dah claim this is the structure for S. So CH double bond CH2 react with hydrogen platinum. So this is the structure for S. Jadi CH2 CH3. So this is the structure for T. Kemudian structure for T, CH2 CH3. So this is structure for T. Okay, react with calcium permanganate followed by hydrolysis, acidic and heat. So dia akan jadi U, which is benzoic acid. Okay. Kemudian S, structure for S. So salin balik S. Ialah CH double bond CH2, so this is S, react with HBr, so tindak balas OB Markovnikov, H will be added to carbon with more H, so sini jadi CH, sini jadi Br, so CH2 plus 1 jadi CH3, okay. Kemudian kita ada S produce W and methanol when undergo ozonolysis. So tindak balas S. Okay. Okay. So tak muat saya sini. So tindak balas S. Okay, undergo ozonolysis mesti nombor 1 with ozone followed by hydrolysis with zinc water. So dia akan potong kat sini. So dia akan jadi C double bond O H, which is benzaldehyde. Kita label ini sebagai W, and methanol C double bond O H. So this is the solution for question number 6B. Okay, so I think that's all for now, and good luck for your exam. So please do a lot of revision sementara kamu ada masa ini. Okay, so that's all from me. Thank you.